In this lesson, we are going to work through fractional and negative indices. This is a higher topic, so it would only be in a higher paper. It can be in both calculator and non-calculator papers. If it were in a calculator paper, you would have to show all of your steps. And in this lesson, I'm going to show you how to deal with them algebraically and how to deal with them normally. So on the screen, I've got two versions of a question. I've got a fractional indice and I've got a negative indice. When you've got a fractional indice, the denominator goes to the front and becomes the root. So a fractional indice actually means that you're dealing with a root. And so what this question is specifically saying to me is I want the cube root of 8. And the cube root of 8 is 2. Whereas on the other side, we've got a negative indice. And when you've got a negative indice, it turns into a fraction. I realize that's heavily confusing, but that's just how it is. I like to pretend that this negative becomes a line and then you've got a fraction, and that might help you remember it. But what you've got here is 1 over 8 squared. So instead of a power of negative, the power now becomes positive, and then 1 over 8 squared would be 1 over 64. All right, so I've now added some questions for the fractional. And I've got various fractions. I've got a half, a third, 2/3, 3 over 2. Generally speaking, those are the only fractions they use. They can sometimes use a fifth when they're dealing with 32, but we're not going to worry about that too much. So if a third is the cube root, then a half is a square root. So 49 to the power of a half is 7, because it's quite literally just asking you for the square root of 49. So what would be 25 to the power of a half? 25 to the power of a half would be 5, because it's asking you for the square root of 25. 27 to the power of a third means the cube root of 27, and that would be 3. Now, 425 to the power of 2 over 3. The 3 is the root, so I want the cube root. And once I've got that cube root, the 2 is the power. So what this question is saying is I want the cube root of 125, and then I'm going to square that. So the cube root of 125 is 5. 5 squared is 25. For 16 to the power of 3 over 2, the 2 is the root. So it's the square root. The 3 is the power. So it's asking you for the square root of 16 and then cubed. So the square root of 16 is 4. 4 cubed is 64. Those are powers those are when the power is a fraction. All right, so now I've got a whole bunch of negative indice ones, and we're going to play around with them. And then I've also put in some fractional ones just to show you how it works. So that negative on top of the on top of the x would be 1 over x to the power of positive 3. So so that power, which is negative, means that it goes under the line, and then x cubed is just x cubed. For the next one, it would be 1 over 8, because that power of negative 3 becomes 1 over, and 2 cubed is 8. Now, for the one after that, things start getting a little bit more interesting. From the previous work, we know that a fractional indice means a root. So 16 to the power of a half means the square root of 16, which is 4. The negative means it goes under the fraction, so it becomes 1 over 4. Right, so just to reiterate, what we're actually saying is 1 over the square root of 16. That is what it was. Now, when there is a fraction inside the bracket, things get a little bit more interesting. The negative tells me that it turns upside down, that the fraction changes. So instead of being 3 over 5, it becomes 5 over 3, and now the power is positive. So when the power is negative, the fraction turns upside down, essentially. And so now what you've got is 5 squared, which is 25, and 3 squared, which is 9. Now the difference between that and the last question is that the power is a fraction, and a fraction means a root. So firstly, I'm going to say 25 over 4 instead of 4 over 25, but I'm now changing the power to be positive. Then because the power is a fraction, we are actually getting a root. So it's the square root of 25, which is 5, and the square root of 4, which is 2. All right, make sure that you have written all of that down. I'm going to ask you to pause, or whatever the case might be during the video, and write these things down, learn from them. Right, so these questions can sometimes cause a little bit of drama. What I often see is the following mistake. So I don't want you to write this down, but this is the following mistake I see. I see 3x squared, and that's what a lot of students write down. Now, the reason that that is wrong is because that power belongs to the 3 and it belongs to the x. So in other words, what the question is actually saying is 3 squared, which is 9, and then x squared. So the actual answer is 9x squared. Now, if we take that and we're going to look at the second question, that half belongs to the 9 and it belongs to the 6. So I've got 9 to the power of a half. What does the power of a half mean? It means square root. So I've got 9 to the power of a half, which is actually 3. Then a power raised to a power means you times. Okay, so a power raised to a power means you times. So we're saying 6 times a half. So 6 times a half is 5. 6 times a half is 5. 6 times a half is 3. So it is 3x to the power of 3. Okay, so a power raised to a power means you times. So 6 times a half is 3. All right, let's look at the last one. I've got 2 over 3. And it belongs to the 64. And it belongs to x to the power of 12. All right. What does power of 2 over 3 mean? The bottom, the denominator, is the root. So I want the cube root of 64. The top number is the power. So then I'm going to square that. Right. So the cube root of 64 is 4. 4 squared is 16. So I've got 16. Then I'm going to say 12 times 2 over 3. So the easiest way to do this would be 12 divided by 3 times 2. Personally, that's what I would have done. So 12 divided by 3 is 4. 4 times 2 is 8. So I've got x to the power of 8. All right, so make sure you've written those down and you've learned from them. So I've now given you some questions. I want you to pause the video at this point. Try these questions on your own. And when you unpause, I'll give you the answers to all of them. So I suggest you pause the video now. Okay, so hopefully you've tried all the questions. Here are the answers. For question D, I've just simplified further to 3 over 2. If you desperately want to write that as a mixed fraction, you're more than welcome to, but this is fine. I hope you've done well. Following on in this video, we're then going to do more exam-style content and a lot more tricky questions. So make sure you're good with this stuff first before you move on. All right, so here we've got an exam question. I can't remember which paper this came out of, but it was quite a good one. What you need to do is put everything as a base 3. So they expect you to realize that 9 can be written as base 3, in other words, 3 squared. Root 3 can be written as base 3 because you can turn it into 3 to the power of a half. So they want you to write everything in terms of base 3 and then answer the question. So let's start with the first part. I've got 3 to the power of a is equal to 1 over 3 squared. So I've turned 9 into base 3. But it's a fraction, and we don't want those. So what I'm going to do is I'm going to take that power, which is positive, but underneath a fraction, and I'm actually going to turn the power negative. So I'm using my laws of indices backwards. Now, if I've got one base on either side, and it's the same base on either side, I get to drop it, and the powers become equal. So in other words, a is negative 2. So I've now got the value of a. Right, we look at the second one. We've got 3 to the power of b equals 9 root 3. So 9 I can write as 3 squared. And root 3 I can write as 3 to the power of a half. Right, now the law of indices says that if you are multiplying the same base, you add the powers. Okay, so the laws of indices state, if I'm multiplying the same base, and 2 brackets touching means multiplying, I add the powers. So in other words, I have got 3 to the power of 2 and a half, because I'm quite literally just saying 2 plus a half. And again, I've got the same base on either side. I can drop that. So b is equal to 2 and a half. Let's do the last one. So I've got 3 to the power of c is equal to 1 over. Now root 3 is 3 to the power of a half. So I've written it as base 3. But just like the first one, I don't want that big fraction. So I'm going to say that it is 3 to the power of negative 1/2. In other words, I brought it above. Make the powers equal, and c is negative 1/2. And now I can actually answer this question, a plus b plus c. So a plus b plus c, a is negative 2, b is 2.5, c is negative 1/2, and the answer is 0. I'm going to now give you another question. It's exactly like this one, and you guys to try it on your own. So pause, write all of this down, and when you unpause, there'll be a new question on the board. All right, so here's a question for you. It's very similar to the previous one. Again, I'm just going to go with a plus b plus c. I want you to pause, try this one on your own, and when you unpause, I'll go through it with you step by step. In this case, everything is going to be base 2 because it's 2 and 2 and 2. So the base is always a prime number. So it'll be base 2, base 3, base 5, things like that. I want you to try this one on your own. All right, so let's have a look at this one. Let's start with the first bit. So I've got 2 to the power of a equals 1 over. 8 can be written as 2 cubed. There's a fraction, don't want that. So I'm going to turn it into a negative power. So I've got 2 to the power of a is equal to 2 to the power of negative 3, which means that a is negative 3. Look at the second bit. I've got 2 to the power of b equals 4 can be written as 2 squared. And root 2 can be written as 2 to the power of a half. Now, for this one, I've got the same base. I'm dividing. If you're dividing, you subtract the powers. So you're going to say 2 to the power of b is equal to 2 to the power of 1.5. Because 2 take away a half is 1.5. And then for the last one, 2 to the power of c is equal to 16. You can write as 2 to the power of 4, and then that's to the power of 2. A power raised to a power means that you times. So I've got 2 to the power of c is 2 to the power of 8, which means that c is 8. Over here, I forgot to write b is 1 1/2. All right, so I've got a plus b plus c. My a was minus 3. My b was 1 1/2. My c was 8. So 8 take away 3 is 5, plus 1.5 is 6.5. All right, if you didn't get it, hopefully you've got it now. Can you make sure that you've written it down, learned from it, copied it, tried it again, all of those beautiful things. Okay, here's another exam style question. I want you to try it first on your own, just to see what you can come up with, and then I will definitely go through it with you. So have a go first. Right. In this particular case, everything is going to be base 3. So there's my base 3. It's a prime number. 27 can be 3 cubed. 9 can be 3 squared. So everything can turn into base 3. So I'm going to turn that 9 into 3 squared. And then it's to the power of negative a half. I've got 27, which can be written as 3 cubed. And it's to the power of a quarter. Divided by 3 to the power of x plus 1. Now, I would suggest that you put a bracket around that. It's always a good idea to put brackets around anything that's got more than one term. We've talked about this already. A power raised to a power means you times. So 2 times negative a half would be negative 1 equals 3 to the power of 3 over 4 divided by 3 to the power of x plus 1. Right, here we are dividing the same base. When you are dividing the same base, you subtract the powers. And that's where this bracket is very, very important. So I've got 3 to the power of negative 1 equals 3 to the power of 3 over 4, take away x plus 1. Now, if you forgot that bracket, you are going to get that plus 1 incorrect, because in my next step, I'm going to expand. So I've got the same base on either side. I can drop the base. Powers become equal. So negative 1 is equal to 3 over 4. Negative times x is negative x. Negative times 1 is negative 1. See, so without that bracket, you are going to write plus 1, which would be wrong. Now I'm going to solve for x. So this minus x I'm going to bring across. So I'm going to say positive x. I've got 3/4 minus 1. This minus 1 over here is going to go over to the right. And change to positive 1 or plus 1, which means that x is 3/4. Right. Pause, copy it down, learn from it. This is a great question. This one actually could very well be in a calculator paper, but you won't be able to do it on your calculator. It won't really work, or at least you won't be showing all your steps. Now, the root is a 4. So what this is actually saying to me is I want the 4th root of 81, and I want the 4th root of 10 to the power of 8. That is technically what it's saying to me. Now, the 4th root of 81 is 3, and I will forgive you if you don't know that, but it is 3, I promise, times by. Here, the laws of indices say that I'm going to take that 4, I'm going to put it underneath the 8. So in other words, it becomes 8 divided by 4. So this ends up becoming 10 to the power of 2. And now the question is really, really straightforward, because I've got 3 times 100, and so the answer is 300. It's actually a really brilliant question. So I'm going to give you one very similar to this that you are going to try on your own. All right, so there's one for you. Give it a go and press pause, and when you unpause, I will put the answer on the screen. All right, so my answer is 4,000. How did I get that? I first split up the root. So I've got the cube root of 64 and the cube root of 10 to the power of 9. Cube root of 64 is 4. That 3 is going to go under the 9. So it's 9 divided by 3, which is 3. That's actually 1,000. 4 times 1,000 is 4,000. Great. Here's another exam style question. Again, power of 3 actually means base 3. I don't want you to get confused. It doesn't mean that the powers are 3. It actually means that the bases are 3. So this is already base 3. That's great. 9 has to turn into base 3. So 9 can be written as 3 squared. There it is, base 3. So I want you to try this question on your own. Remember that when you are dividing the same base, you subtract the powers. So there's a little hint. Pause, try this on your own, and then we'll go through it. All right. So on top of the line, I've got 3 to the power of n over. Under the line, I've got 9. Now 9 can be written as 3 squared. And then that is to the power of n minus 1. So now it's the same base, which is great. So I've got 3 to the power of n over 3 to the power of 2n minus 2. Okay, so what I did there was I said 2 times n, 2 times minus 1. Now, do you remember in a previous question, I said put a bracket around it, because when you have a minus, things change. Same thing's going to happen here. I've got the same base. So if I've got the same base, and you're dividing, you subtract the powers. So I'm saying 3 to the power of n, take away the 2n minus 2. So it ends up becoming 3 to the power of n minus 2n plus 2. And it's because of that negative. See, this negative is going to go to 2n, and that negative is going to go to the negative 2 and make positive 2. Right, so my answer is 3 to the power of n take away 2n is minus n plus 2. And that's my final answer. All right, this is a nice one. Everything is already base 2. You're just using the laws of indices to solve for x. Write down this question, pause the video, try it on your own. Here, remember, when you are dividing the same base, you take away the powers. Don't forget about that minus. You know that it must be equal to 2 to the power of 17. I want to see if you guys can try that on your own. Okay, I hope you gave it a go. I have got 2 to the power of 3x over 2 to the power of x minus 5 equals 2 to the power of 17. That's the question. As I said before, when you're dividing, you take away. So I've got 3x, take away the x minus 5 equals 2 to the power of 17. So I've got 2 to the power of 3x, take away x, plus 5 equals 2 to the power of 17. I've got the same base on either side, so I can drop it, which means 3x, take away x, add 5 is equal to 17. So I've got 4x is equal to 12, right? How did I get the 12? I took that 5 across and I said 17 take away 5, and that gave me 12. Then I divide by 4 on both sides, and x equals 3. Right, I've got one more question for you, very similar. Again, I want you to try it on your own, and then I'll go through it with you. So this one, everything is base 9. You are actually allowed to leave it that way because they are all the same base. If it was a 9 and a 27 and a 3, then you'd want to convert them all to the same base. But seeing that they are all 9, that is actually pretty cool. On the top, you've got the same base, so you add the powers. At the bottom, you've got the same base, and you take away the powers. Again, I want to see what you guys can come up with. Here it says work out the value, as it has in a couple of the questions. It means that they want an actual answer. All right, so we've got 9 to the power of 3. Because I'm timesing on the top, I add the power. So I'm saying 3, add negative 5 over 2. Then, because I'm taking away at the bottom, I subtract, and I'm saying take away 3 over 2. Okay, so I've got 9, and then I need to add all those fractions together. So this little 3 is over a 1. My lowest common denominator is 2. So I'm going to multiply that by 2. What I do to the bottom, I do to the top. And I've now got 6, take away 5, take away 3, all over 2. So I've got 9. 6 take away 5 is 1. 1 take away 3 is minus 2 over 2. So that gives me 9 to the power of negative 1. That's not really a value yet. The actual value would be 1 over 9, because then the powers are all positive, and that is in fact the answer. I really hope you've learned something this lesson, maybe made a few things clearer, and good luck for any exams.